Hi guys, welcome to the session. This is Rajshekhar from St. Peter's Engineering College. Today our topic is about FP growth algorithm. FP growth algorithm means frequent pattern growth algorithm for mining in the frequent patterns. What is an FP growth algorithm? What is a FP growth? FP growth stands for the frequent pattern growths, and it is a scalable technique for the mining frequent patterns in the database. Actually, if when we see in the previous pattern technique, that is an a priori algorithm, as we have seen in many cases, the a priori algorithm or the a priori candidate generates and a test method significance reduce the size of the candidate sets and leads to a good performance again. However, it can also suffer from the two non-retrieval causes. One, why? Because in our algorithm, we have to scan the database in multiple times to get the frequent patterns. So we are getting in a multiple, we are increasing the size of the scanning times. It may needs and generate a huge number of the candidate sets. For example, if there are a 10 power 4 frequent item sets are available, the a priori algorithm will need to generate more than a 10 power 7 candidates, that is a 2 item sets. Moreover, to discover a frequent pattern, the size of the hundreds, such as a A1 to the A100, it has to generate the at least 2 power 100 minus 1 subsequently to the 10 power 30 candidates in a total. So it may lead to an increasing of the size of the item sets. With this the defect, with this the drawback, the a priori algorithm will have to it gives a more result, it gives a better results, but it may needs to the more item sets, more scanning process will be done, and it may need to a repeatable scan of the database to check in a large set of candidates by pattern matching. So it is a costly to go over each transaction in the database to determine the support of the candidate item sets. For this process only, we are using an FP growth algorithm. In this FP growth algorithm, we need only 2 times of the scannings to get the better frequent patterns algorithms in the particular database. And why the FP growth algorithm only is preferable means FP growth algorithms improves the a priority to a big extent levels. In this frequent item set, where mining is possible without candidate generation also. If you want to generate any candidate, you have to scan the multiple times in the a priori algorithm. In the FP growth algorithm, is possible without candidate generation also done. Only only two scans to the database is needed. But how this a priori algorithm, but how this FP growth algorithm will move on to the process. We have only 2 steps. We are following only the 2 steps in the FP growth algorithm. Build a compact data structure called the FP tree by using the 2 passes over the data set. But because we are using a null as a root node, and after that each transaction will be linked from the null to the next pattern level. The first node transaction only you have to check whether these node transaction will give an better one. So we have to identify the number of we have to scan in the first and only which item set will have an n number of the data sets. So like that we have to check each and every items, that is a transaction IDs from the beginning to the ending, and you have to identify the one main node of that particular data sets. Then the step 2 is an extract the frequent item sets directly from the FP tree. So can we design a method that mines the complete set of the frequent item set without candidate data generations? An interesting method in this attempt is called the frequent pattern growth method, or simply it's called as an FP growth, which adopts a divide and conquer strategies. If you have a 10 number of the items are available, we will scan the overall 10 item set by using the divide and conquer techniques. In this divide and conquer technique means divide the overall data set, divide the overall data item sets into a half part, and scan from those half part in one side and scan another half part in another side. So like this. For example, taken a transaction table of the all electronic details within a transaction ID T100, T200, T300, T400, T500 to the T900 within a 10 transaction IDs, and the list of items available on that particular transaction IDs are I1, I2, I5, I1, I2, I3, I4, I5. So these are all the 5 items are available in that particular transaction IDs. These items only repeatedly moving into the transaction IDs. So scan the overall database in the first preference of the time. then we have to move on to the next stage. So now we'll build a FP tree on the database. The item sets are considered as an in order to the descending value of the support count. So descending value of the support count means here you have to check the database very clearly, that is I1, I2, I5, I2, I4, I2, I3, I1, I2, I4, I1, I3, I2, I3, I1, I3, I1, I2, I3, I5, and I1, I2, I3. So if you check all the database very clearly, here we have what is the maximum support count of the data set is I2. Why? Because this I2 is repeatedly there in that particular each and every transaction IDs. So the support of the maximum support we have, then we are considering as a maximum support node. So when you are taking a transaction IDs, that particular maximum support node will come into the beginning, and next nodes will go to the next one. So now we'll build an FP tree of that particular database. Item sets are considered in order for the descending value of the support count. First ID transaction, that is a T100. What is the T100 transaction list of items? I1, I2, I5. So we are taking as a for transactions I2, I1, I5. Why? Because I2 will come into the beginning means the maximum support count, the maximum strength of support count will be the I2 is the first ranges. So we are giving as a null as a root node. From the left side I2, I1, I5. So I2, I1, I5. When these I2 will come into the second time, we are moving into I2 only, and keeping the number of support count as an 2. The next transaction ID is I2 and I4. Then what is the transaction ID of the 200? T200 is I2 and I4. The second transaction ID T200 is I2 and I4. So we have an already null root node, and I2 is the second time repeated. So we are changing that one as an I2 as an 2, and connecting to the I2 with I4 as 1. Why? Because the I4 is repeated in single time. The next transaction is what T300 is I2 and I3. So here the third transaction is I2 and I3. So it's already I2 is there. There is previously we have an I2 2. Now we are again getting an I2 as a third transaction. So we are moving as an I2 as a 3, changing into the I2 as a 3, and we are connecting these I2 as I3 1. Why? Because the I3 is the first time it's coming. So we are giving an I3 1. The next transaction is I2, I1, I4. So I2 is already there. So we are changing the I2 value as a 4. That's the fourth time it's repeated. And the next one is I1. I1 is also already there. So we are changing the I1 as a second option. The next one is I4. So we are giving the connectivity to I4 as 1. So here the I2, I1, I4. I2, I1, I4. So the next transaction is I1 and I3. Here the I1 and I3. Why? Because already I1 having 2 transactions and I4 having 1 transaction. So it is not possible to give the connectivity with an I1 and I3. Why? Because the I1 has a 2 and I3 has a 1. So I2, I1 is already connected in the left side. So we are moving it's an I1, I3 within a separate connection, that is I1, I3 will be entering into the right side of that particular transaction. Right side of that particular transaction here. The next transaction is I2, I3. So it's already there in the I2. Here the changing value is I2 as an F5. I2 as an F5 and I3 is changing into the 2. The next transaction is I2, I1, I3, I5. I2 is modifying into the 6th one transaction, and I1 is modifying into the 3, and I3 is there already 1, that is I3 1, and I5 1. The next transaction is I2, I1, I3. I2, I1, I3. So we are updating the value of the count, that is a support count value of the value will be updated. I2, I1, I3. So With this, all the transactions has been completed, and after the transaction has been completed, we have to check all the values. Those are already there or not. That means I2, I1, I5, I3, I5. So all the trees are completed. Almost all the FP tree is constructed. So this is the FP tree is constructed. After constructing the FP tree, we have to facilitate the tree travel cells to that particular values. Now identify the nodes of that particular one. The first one is I2. I2, second one is I1. So here we have to check the maximum values. How many times this I2 is repeated means 7 times. So I2 value is 7. Next one is I1. How many I1s, how many times I1 is repeated? So here I1 is repeated as a 4 and I1 is repeated as a 2 here. So 4 plus 2 is 6. Next, how many I3s? How many I3s are repeated? I3s are repeated here from I3 2 and I3 2 4 and I3 2 here. That is a 2 2 2 is a 6. Next one is I4. How many times I4 is repeated? That means how I4 count means I4 1 here, I4 1 here. So both will be joined and it will be counted as I4 2. The next one is I5. How many times I5 is there in that particular transaction process means I5 is 1 here and I5 is 2 here. So both will be connected and the tree via chain link will be connected and displayed in the I5 2. So this is the maximum count of the transaction values here. To facilitate the tree travel cell, an item header table is built so that each item points to its occurrences in the tree via a chain of the nodes will be displayed here. And this is the FP tree construction over. Now we need to find out the conditional parameter base and the conditional FP tree base for each items. So by basing on these FP tree, we have to construct the conditional parameter base. The conditional parameter base will shows you the, we have to coming from the down of that particular tree. Down of the particular tree means bottom of the values. What are the bottom of the values? I5. From the nodes which are connected from the I5 will be considered as a conditional parameter base. So the I5 will be connected to the I1 and I2. So the base node is the I2. So we are moving to the I2 and I1 is an 1 and the second one I5 also here. I2, I1, I3 is the second one. If there is any I5 is there in the root node, leaf nodes, so there is no leaf node. So the conditional parameter base of the I5 is I2, I1 and I2, I1, I3. These are two sets of the conditional parameter base has been constructed. So here we have a conditional FP tree for I5 is I2 2, I1 2. I2 is repeated in 2 times, I1 is repeated in 2 times, so I3 is repeated in 1 time only, so we are neglecting that one. So the conditional FP tree for I5 is I2 2 and I1 2. The next we have to write on the conditional parameter pattern basis I4. Where is the I4? I4 is here. So for the I4, what are the connected nodes are? I2, I1 is the first one and the next one is I2 only. So here what the conditional FP tree for I4 is I2 is repeated twice and I1 is repeated once. So we are neglecting the I1 and we are considering as an I2 2 times. Next the conditional pattern base is I3. I3 pattern base is I2, I4 is the first one, that is I2, I1. I2, I1 is the first one. Here I2 is the second one and here I1 is the third one. So here the conditional FP tree for I3 is I2 is repeated twice. I2 1, I2 in twice and I2 in twice here. So in I3 we have values of the I2 and I2 and I1. So on the I3 have an I2 and here I3 have an I1. So this is a conditional pattern base of the I3, and the conditional FP tree for I3 is I2 is repeated in the 4 times, and I1 is repeated twice, and I1 is 2. So here the values of the conditional FP tree of this I3 is I2 4 and I1 2 and I1 2. The next one is for I1. So in the I1 we have an I2 is 4 times, and here we don't have anything. So I1 have an I2 4. The conditional FP tree is I2 4 here. This is a frequent pattern generator by using the FP growth tree. That is a I5, I2, I5 2. So each and frequent pattern will be managed with this I5, I5 2 and I5 2 here. So this is the frequent patterns generated by using the database with an 2 times of the scanning of the FP tree. So this is the graph with the FP growth runtime and FP growth given is a runtime. So here if you check this line bar, this is the FP growth runtime. So in this FP growth runtime, we have less time of the scanning process. In this D1 is an a priori runtime. So in this D1 a priori runtime, we have a high of the scanning time. So by this scanning time process, it shows very clearly that FP growth have a better results, and the same quality will be maintained with an a priori algorithm with the data mining. So this is the FP growth algorithm. Thank you.